Now in this section, we are going to learn how to find the derivatives using formulas. Okay. So the formula we studied before proves that in some special case is a derivative of the power function. So it's called the power rule. Okay. So it says that the derivative of x to the n is going to n times x to the n minus 1. Now this n is not necessarily to be integer. N can be any number. Okay. And here where n can be any number. Okay, not necessarily to be integer. Okay, so for example, if you use this formula, you can easily find the derivative of 1 over the square root of the derivative of 1 over square of x. Otherwise, if you use definition, it takes much more time. Okay, so how to do that? You express it as a power function, which is going to be x to the negative 1/2. So n here is negative 1/2. Then you use a formula, n should be in front of x to the n minus 1. So then you simplify it. Maybe this is the answer. Okay. Yeah. You don't need to change the expression in the traditional form involve radicals. Okay, this will be the answer. Well, if the function is a sum of a power functions, how can we find the derivatives? We need a following formula. It's easy to prove. This is another formula, the derivative of f of x plus minus g of x. Okay, you just need to differentiate each term. I would like to put a constant here, a and b. Okay, so you take a out, you differentiate f of x plus b, differentiate g of x. So in this case, if I use the arbitrary number, then I don't need to put plus minus here. I just say the sum. Okay. So b can be a negative number. Okay. So that's called the linearity of the derivative. It's a linear combination of two functions. If you differentiate them, you just need to differentiate each function here, then use the same linear combination. Okay, so this is very nice. You know, we just differentiate each term. Okay, for example, using this, I can differentiate 3x plus x to the 4th power. So this is a linear combination of two power functions. It's a polynomial. Okay, how do you do that? You take 3 out, differentiate x, and then you differentiate x to the 4th power. Then you apply the power rule. It's a 3. The derivative of x is 1, and the derivative of 4x x to the 4th is 4x cubed. Okay, so that is the answer. Simple. So now we can differentiate any polynomial. Okay, any polynomial. So you can differentiate even now, a combination, right, of any power function. Power function can be x to the some fractions even, right? Just like, so it can be the x plus square of x, for example. You can also do that. So you can put 3 here, 2 here. It's a linear combination, okay? So you do the same. It's a 3 derivative of x, right? Plus twice derivative of square of x. Right. Square of x is a power function. It is x to the 1/2. So here's 3. Derivative of x is 1. and twice the derivative of x square of x is 1/2 x to the 1/2 minus 1. Right. Then you simplify it, you get x to the negative 1/2. So that's it. So let's look at the long polynomial. It's 1 minus 3x plus 4x squared minus 7x cubed plus x to the 5th, right? Even a very long polynomial, right? So the linearity shows you that you can differentiate each term, then add them together, okay? Here, for the simplicity, we just have af of x plus b of x. But you have more than 2 terms, that's the same, okay? So you differentiate the first term, minus 3, differentiate the second term, plus 4, differentiate x squared, minus 7, the derivative of x cubed, plus the derivative of x to the 5th. Then you simplify it to 0, minus 3, plus 4 times 2x, minus 7 times 3, x squared, and plus 5 times x to the 4th. Okay, then you simplify a little bit. It's going to be negative 3 plus 8x plus 21x squared plus 5. All right, so what, although the sum of several terms, you can use the formula, above formula for the sum of 2 functions. Okay, it's a similar formula. Suppose you have more than 2, more than 2 terms, right? It's the derivative like f1, a1, x, a2, f2x, and so on. The general ak, f of kx, right? Because we have more than 2 functions, we prefer to use the sub-index for the name of to name the functions. Okay, so you get it. It's not surprising that you get this. All you have to do is just differentiate each function, then add them together. Use the same linear combination. Right? So it's polynomial. You have a bunch of power functions. Now, not every function is expressed directly as a sum of power functions. So you have to modify the function to solve the problem. Okay. For example, like, if f of x equals like x plus 1 of x squared, find the derivative of the function. Okay. So this is a square. X plus 1 of x is the sum of 2 power functions because 1 of x is the x to the negative 1. So it's power function. But now x plus 1 of x squared, it does not look like a sum of power functions. But you can modify it. Okay. So step 1, you have to modify. It's going to be x squared plus twice x times 1 of x plus 1 of x squared. Okay. So you simplify x squared plus 2 plus 1 of x squared. Now this becomes a sum of a power function. Okay, so more precisely, it's going to be, okay, just power function, x to the negative 1, negative 2, x squared, right? So now the derivative of this function, you have to differentiate each term. Okay. So you get 2x, 0, negative 2x to the negative. So that's it. This is negative, yes. Okay, so this is answer. Okay. If you have to differentiate x squared minus x and x plus 3. So this is a product of two functions. Okay. Some of you took this course before. Maybe you can say, oh, I heard about this product rule. Right? I can use the product rule to find the derivative. But this essentially is a polynomial. So you can express as a polynomial. It's a sum of power function. So x cubed plus 3x squared minus x squared minus 3x. Okay, so you simplify it. Okay, so you get 3 terms. Now it's a sum of power functions, right? So you can differentiate each term, then add them together. Okay, so write down what is the derivative of x cubed? 3x squared. 2, it's 2x minus 3. Simplified. Okay, so this is a derivative. As you can see that sometimes we have to deal with the product of two functions. Okay, you can show that there's another formula. It's product of two functions. Okay, and for product of two functions, it's not going to be the product of two derivatives. Okay, this is actually, you have to differentiate the first term. Let's still use d over dx. That's the same notation. Okay, so you differentiate the first function, you copy the second function, then you take a term. It's not going to be the derivative of, it's not going to be the product of two derivatives. Okay, so when you differentiate the product two functions, you get two terms. We can verify this using the definition of the derivative, no problem. All right, so we can do the same problem using the above formula. Find the derivative. Okay, how to do that? Well, by the product rule, you differentiate. Yeah, if you don't want to use the d over dx, and you simply write the product of x, the first term, copy the first term, then the product of the second term. Yeah, the derivative, yeah, product of the first term times the derivative second term. Okay. So the derivative x squared minus x will be 2x minus 1. And here will be, here we win, because that's it. Should you simplify it? Yeah, it's better to multiply this out and simplify. So you get 2x squared plus 6x minus x minus 3. X squared minus x. Then you simplify it, you get 3x squared. 6x minus x is 4x minus 3. So you get same result no matter which method you use. All right, let's do this. Yeah, you can try. I'm ready to try first. It's a product of two functions. You still have two options. You can either view that it's a product of two functions, or in some cases you can change it to the sum of the power functions. And this is the case. Okay. I try not to use a product. Okay. So this function square x 1 minus x is going to be, it's going to be, right? It's 1/2, right? X to the 1/2. So it's multiply this out, minus x, 1/2 plus 1, 3/2. So it's a sum of two power functions. Then the derivative is going to be very simple. Okay, it's going to be the derivative of x to the 1/2. Right? So you differentiate each term. 1/2 minus 1 is. Then you simplify it. All right. So this is the answer. All right. If you don't like the fraction power, you end up with this. Okay. But you can also use a product rule to find the derivative. You should be able to get the same answer. So the product rule here is going to be square x prime 1 minus x plus square x 1 minus x prime, right? The product. All right. So that is going to be 2 square x. We already got before. And this is just -1. Okay. The derivative of 1 minus x is -1. All right. So let's multiply this out. Okay. X over square x is just square x. Okay. Then combine those two terms together. You get this. Do you get the same result? No, I'm sorry. Yeah, it's the same result. Compare this. Compare with that one. All right. All right. So you try this. Please do it. All right, so this is x squared minus 4 divided by x. It's not the sum of the power function. It is not product. Well, it can be viewed as product to functions. Why? Because there's only one single x there. Okay, you can view it as product to functions. Yeah, let's see. I'm not going to write this. So let's modify the function. Okay, x squared minus 4 over x. Okay, this can be viewed as 1 of x times x squared minus 4, right? This can be viewed as x to the -1 times x squared minus 4. So now it's product of two functions. Okay, power function times a polynomial. But you can also multiply this out, will be x, okay? So it'll be x minus 4 times x to the negative. So it's another way. Then this becomes a sum of power functions. I like the last version. I can apply product rule to this to differentiate this function, right? But if you look at the last expression, then you decided to differentiate the function using the power rule. Right, so it's going to be derivative of the first term minus the derivative of the second. It's a 1 minus 4 times -1 x to the negative 2. All right, so simplify a little bit. It's 1 plus 4x to the negative 2. So this is a function. But if I change the denominator, x to the x plus 1, then you have a trouble. You cannot use this method to solve the problem. If I change x in the denominator to x plus 1, then you have a problem. Okay, so we have to learn this the product rule as a quotient rule. Okay, if it's a quotient of two functions, that's going to be GR square. You differentiate the first term, numerator, and then the derivative of the second. Okay. So this is the formula we're going to use. And now, let's still do the same problem, okay, using the formula. And this is a quotient of two functions. Right? According to the formula, it will be denominator square, then the derivative of the numerator times the denominator minus the copy of the numerator times the derivative. All right, so let's simplify it. X squared minus 4 will be 2x, and this is just x squared minus 4. Okay, so we have to simplify. 2x times x, it'll be 2x squared. 2x squared minus x squared, which is x squared plus 4 x squared. Did we get the same answer? Let's look at. Yeah, we get the same answer. Those two are the same. Okay. Why it's the same? It's get x squared over x squared plus 4 over x squared. The first term is 1. The second term will be this. All right. So if we apply the quotient rule, we are still able to solve the problem. But for this particular problem, you can express as a sum of power functions. Okay. Now, how about this? Now this time you have to use a quotient, right? Maybe. All right, let's do it. By the quotient rule, it's going to be the denominator square, and then you differentiate the numerator times the denominator minus the copy of the numerator times the derivative. Okay? So you will get 2x, x plus 2 minus x squared minus 4 times 1. Okay. Are we able to simplify it? Yeah, let's do it. It's going to be 2x squared plus 4x minus x squared plus 4. So you will get x squared plus 4x plus 4. X, yeah, this is a plus, okay? Plus 2 squared. But x squared plus 4x plus 4 is going to be x plus 2 squared. We know that, right? It's going to be x plus 2 squared, x plus 2. And you find out it's nothing but equal to 1. I will go back to the function. But if you simplify function at the very beginning, you probably don't need to waste so much time to find the derivative, right? Why? Because f of x equals x to the fourth minus x, yeah, right? You can factor the numerator and then cancel it out. You will get a linear function. Then the derivative is nothing but 1. 1 minus 0. All right, so you don't need that. So this problem suggests you don't just be in a hurry to find the derivative. You maybe can simplify the a little bit, simplify the function. Right? You have to modify the function to solve the problem. Yeah, that helps you save your time and you know, because the function is simple, so you don't need to waste too much time. Yeah, it's if possible, simplify the function first. All right. All right, so this is a quotient of two functions. Okay, can you find a derivative using the formula I gave to you? Yeah, please do it. There's no tricky here. Let's just go ahead and use a quotient rule to find the derivative. First of all, the denominator square, then the numerator, then the denominator. Okay. All right, so ax plus b is a derivative is just equal to a. And cx plus d is the derivative of c. You know what? Then x is going in the numerator. So you get axx ad minus acx minus bc. And ax cancelled out. You will get ad minus bc, cx minus d squared. Right. All right, let's do the next one. Find an equation for the tangent line to the graph y equals 2x cubed minus x squared plus 2 at 1 and 3. Two and 3 indeed is a point on the graph, because when x equals 2, you get 3. The y value is 3. So how do you solve this problem? Do you want the sketch graph? No, you don't need it. Okay, but all you have to do is find a point here. It's a 1 and 3, and I don't know, just sketch the graph. Let's mark it. Okay, so you are going to find the slope of the tangent line. The slope of the tangent line, how do you find out? It is going to be the dy over dx. Evaluate when x equals 1. It's better to draw the graph and indicate, what is the slope? How do you find it? Okay. So all I have to do is find the derivative function with respect to x. And then it's easy, it's polynomial, right? You differentiate each term. So you get 2 times 3x squared minus 2x plus 0. Okay, so you get 6x squared minus 2x. So that is a derivative as a function. Remember we did it, right? Derivative as a function. So, so this is a new function. It's a quadratic function. Since the origin function is a polynomial degree 3. Now the slope m should be evaluated when x equals 1. And that is going to be 6 1 squared minus 2 times 1. That's 4. It's positive. So once you get slope for the tangent line, and you can get the equation for it. Any equation, because the form is not unique. So y minus 3 equals m times x minus 1. Okay? Here's another question. So I know some function, I know the exact value formula, but the f of 4 equals f of 2 equals 4, and f prime of 2 equals negative 3. What I want you to find out is the derivative of hx divided by x when x equals 2. We are going to find the derivative of this quotient at x equals 2. But I don't know the formula for h of x. How can I find the derivative? Yes, you cannot find the derivative in general, okay? But you can, at least at this particular point, you can find the value of the derivative of this function, h of x over x. Okay, so let's do it. According to the quotient, right, it's going to be x squared, the derivative of hx mod x minus what? Right? Then what? We're trying to simplify a little, right? So you get, let's use h prime x, x, right? And this side is just x squared h of x, right? Divide separate. That's okay. You can put together separate, doesn't matter. So now when x equals 2, okay? So the derivative, I have to rewrite this again. And x equals 2 is going to be h prime of 2 and 2 minus h of 2 and 2 squared. So already given the value of this, it's going to be negative 3 over 2 minus 4 over 4. Okay? So that is going to be negative 3 over 2 minus 1. It's negative 5 over 2. That is it. You don't need to know the exact value of the. You don't need to know the formula for the derivative for the function. Okay? But don't forget to simplify the function if possible before you find the derivative. Right? So this is here's another problem. F of x equals x minus 1 x cubed plus 2x minus 1. find the derivative. You may ask, how can I simplify this function? Well, if you don't want, it's fine. Just use the quotient rule and like to find the derivative. You still can simplify a little bit. Yeah, the idea is that it's a polynomial divided on another polynomial. It's what we call the long division, right? X cubed plus 2x minus 1 divided by x minus 1, right? Do you remember that? You differentiate, you get an x squared. So x cubed minus x squared. You multiply each term, x minus 1 times x squared. Then you do the subtraction, just like a usual division. So you get x squared plus 2x minus 1. Okay, so first term minus second term. X squared first expression minus second expression. So x cubed is gone. So 2x minus 1 minus negative x squared, you get x squared. Right? So now you have to put x here. So you get x squared minus x, then do subtraction. So you get 3x minus 1. In order to get 3x, I have to put 3. So 3x minus 3, take the difference, negative 1 minus, so it's 2. Okay. What does this mean? This means if you divide x cubed plus 2x minus 1 by x minus 1, you get a quotient. You get a remainder. Remainder is constant. So f of x is going to be x squared plus x minus plus 3. The remainder, So that is, right? So that's the expression actually much better. So even want to find applying the product quotient rule, but the second one, last one is 2 over x minus 1, much simpler. So f prime x is going to be x squared is going to be x prime plus 3, and then apply the quotient rule here, 2x minus 1 minus 2, right? So the first term is going to be 2x plus 1. The second term here, I think it's all 0. It's minus 2x minus 1 squared. So that is answer. If you don't want to simplify it first, you still can do the computation. No problem. X cubed minus plus 2x, right? So you can try it again. Let's see how complicated it is. X cubed plus 2x minus 1, right? That's my original function. Let's go back to yes. We differentiate using the quotient. So get x minus 1 squared, then x cubed plus 2x minus 1 minus this is a quotient. All right, so now you get 3x squared plus 2 minus x cubed plus 2x minus 1 times 1. Okay. Should you simplify? Yeah, but before you have to simplify a little bit. You cannot just leave like that. This is not a final answer. You have to simplify. You multiply this out to be 3x cubed plus 2x minus 3x squared minus 2 minus x cubed minus 2x plus 1. Okay. Then how many x cubed there? So you get 2x cubed minus 3x squared. 2x is gone, and minus 1. Okay, so this does not look like the same form like we did before, but this should be the same answer. Okay, yeah, compare with the one above. Yeah, we should get the same answer. Okay, that's the same. So the answer key will be, it's not unique answer, could be in different form. Sometimes we have to deal with an inverse problem, like find the C at which f prime c equals 0. Now here's f of x is going to be x plus 1 of x. Okay. Now look at this function. This function is defined. Yeah, if you draw the graph, yeah, when the x is positive, it goes like that. Okay. But if x is negative, all the terms negative. So it goes like this. Okay. Find the number c at which the derivative is 0. What does that mean? We are looking for the number. We're looking for the point on the graph such that the tangent line is horizontal. In other words, yeah. So in other words, we are going to find the point, okay, at which, yeah, the point, yeah, at which the tangent line is horizontal. Okay. So if you look at the picture, I think I'm going to get 2 points, 2 solutions, because this is this is right. The tangent is horizontal. I should have 2 solutions if I know the graph. All right. Now, how do you find the derivative? Well, the derivative is simple. If you understand the question, then you can solve the problem easily. So the function can be written as the sum of the power functions. So the derivative is going to be 1 minus x to the negative 2. And we have to set this to be 0. Now, I should have said that there are students have a scared about this kind of equations. Okay? For Math 165, at the very beginning, sometimes I give an entrance exam for the first class. I didn't review. And this is one of my favorite equations I put on it. And half of the students couldn't solve it. Okay, especially if you have like a negative power, yeah, it's not like a usual equation. So can you solve it? Try. 1 minus x to the negative 2. You will see such equations very often in the near future when we try to apply calculus to solve a story problem, like maximum, minimize volume, maximize area, something, and you end up with an equation like that, right, with negative power. I give you 1 minute, find the solution. Solving this kind of equations do not belong to this course, okay? I will show you how to do it. It's a pre-calculus. How many solutions you get? It looks like you only get one solution. Yeah, plus minus one. Yes. Okay, so we write this equation. Now, this is the equation, right? You can do like this. You multiply both sides by x squared. That's one way to do. So you get x squared minus x to the negative 2 times x squared is 1. So you change the equation to this equation. Then x squared equals 1 implies x equals plus minus 1. Okay, so you get two solutions. And you double check, right? Another way to solve this equation is 1 minus 1 of x squared equals 0, right? I can get this. Then you can also turn upside down, or you get 1 of x, right? And you can say 1 of x squared equals 1. That implies 1 of x equals plus minus 1. X equals plus minus 1. It's clear. Okay, so then you get the solution. You get 2 points, and at which the tangent line horizontal. Those called inverse problem. In engineering mathematics, there are lots of inverse problems. Okay, sometimes you get a question and some unknowns quantity satisfying equation, and you're trying to solve it. Solving differential equation is actually just the inverse problem. Okay, you're not given the function, find the derivatives. You know that the derivatives of the function satisfy some equation, and you're trying to find out that function, right? And sometimes you can solve it, sometimes you cannot solve it using elementary function. You only know the solution exists. Then you're trying to study the behavior of the graph of the solution. Okay. So if you are engineering major, there are many courses ahead of you. Okay. This is the first one. Calculus course is the first course. Calculus 2, Calculus 3, and then differential equations. Okay. And we also have a joint program with the electronic engineering. If you get the math major here, then at 1 more year, you can get master degree in electronic engineering. Okay. But you have to basically, before you get bachelor degree, your elective courses should be in engineering. Okay. All right, so let's stop here and take a quiz.